In this particular video, we're going to talk about how to add and subtract unlike fractions. Now, before I actually get into how to do it, let's talk about why. Because we know that when we're talking about adding and subtracting unlike fractions, we're supposed to have a common denominator, but most students don't really understand why. So I'm going to show you an example of why this is. So let's say, for instance, that I really like pie, and I'm not just talking about the symbol pi, I'm talking about like actual pies. And here's what happens. I have a student who bakes 2 pies. They take out a ruler, measure all the way around, make sure it's completely circular. And we are going to have to use our imaginations a little bit with this picture I've drawn because my 2 circles are not quite perfect. But we've got these 2 circular pies that are completely circular, perfect all the way around. And here's what happens. They bring these 2 pies in. Now one of these pies is for me and the other is for the rest of the class. Here's what I'm going to do. I'm going to split my pie up into thirds, and we're going to pretend like I'm splitting this up into exact thirds. Now the other students are not quite as stingy as I am, and they're going to split theirs up into sixths. And once again, we're pretending that these are perfect sixths. And here's what happens. I'm looking at these 2 pies, and I'm like, oh wait, I need to call for a break. So I asked everybody to leave, and while everybody is gone, I eat this piece, and 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 let's not forget this piece. So everybody comes back in and they're like, oh my gosh, you have eaten a whole entire pie by yourself. And I'm like, no, I know. You can't prove that the way it stands. So why can't we prove that with like this? And the reason we can't is because the pieces of the pie are not the same. But here's what happens. We know by math, right now I have eat 2/3 of this pie. And this other pie I have eat 4/6. Well, what happens when I split these thirds into halves on this first pie? Let's say I split this into half. And this into half. And this into half. Here's what happens. It actually turns out 2/3 is equivalent to 4/6. So when we talk about coming up with common denominators, the whole point of doing that is to make sure that we have the same denominator, that we have the same number of pieces. Otherwise, you can't add them together, and the pieces have to be the same size. So now that we've come over and got a common denominator, which ended up being 6, we can actually add these 2 things together, giving us a total of 8/6. Well, meaning, of course, that I ate a whole entire pie. Let's look at this in the context of another example. I'm going to throw some negatives in here just to make it more entertaining. So I've got this other example here. So negative 5/14 plus 3/7 minus 1/2. And of course, with this particular example, not only do we have to find the common denominator, we've got the negatives to deal with. So when we look at 14, 7, and 2, I'm looking for the smallest number that everything goes into. So we're thinking multiples of these numbers. Don't think factors. A lot of students want to look at this problem and say something like 2. That's not going to work. You got to look for something that everything multiplies into. So if I think about factors of 7, well, 1 times 7 is 7, 2 times 7 is 14. Okay, well, we've got 14 too, so that looks like a good number. And of course, 2 can multiply by 7 to give me 14. So let's use 14. So what I want to do is I'm going to make sure I put a 14 on the bottom of every single one of these. And then I'm going to have a conversation with myself. So I'm going to look at this and I'm going to say, okay, well, what do I need to multiply 14 by to get 14? Well, that would be a 1. Well, if we do it to the bottom, or if we multiply the bottom by 1, we also have to multiply the top by 1. So if I do 1 times negative 5, that's going to give me a negative 5. In other words, this particular fraction did not change, and that makes sense because it already had the common denominator. Okay, let's look at the 7. What would I have to multiply 7 by to get 14? Well, that needs to be a 2, and if I multiply the bottom by 2, you absolutely positively have to multiply the top by 2. Because 2 over 2 is equivalent to 1, so we're not changing the value, we're just changing the appearance. And of course, 3 times 2 is going to give me a 6. And then finally, what do we need to multiply 2 by to get 14? Well, that needs to be 7. And of course, if we do it to the bottom of the fraction, we absolutely positively have to do it to the top of the fraction if we're talking about adding and subtracting. So 1 times 7 is going to give me a 7. So now that we've done this, we're ready to go ahead and combine everything together since we've all got a denominator of 14. Now guys, one thing I do want to point out, that denominator doesn't change because we are talking about pieces out of 14. Now if you don't like this negative here, we do have the ability to go through and change subtraction to be addition, and we change the sign behind it to be opposite, so that becomes a negative 7/14. So we've got a couple of options here. We can go ahead and combine the two negatives together. So negative 5 plus negative 7 is going to give me a negative 12/14. And then we've got plus the 6/14. And then of course, because the two signs are different and we are adding, we can subtract. So negative 12 minus 6 is going to be a 6. It will stay negative because we had more negatives. And then of course that's over 14. Unfortunately though, we do not like having 6 over 14 because that's not completely reduced. So if we think about reducing, 6 and 14 are both divisible by 2. So 6 divided by 2 is going to be a negative 3. 14 divided by 2 is a 7.